For number one, we're going to have to graph y equals 0.3 to the power x. And I recommend drawing a table. And we're starting at -2, x equal -2, x equal -1, x equals 0, 1, 2. So let's go ahead and type that into the calculator, parentheses, 0.3, close parentheses, raised to the power x. Go to your table, and you want to start at -2. So we know that in -2 it's going to be 11.11, and -1 is 33.33. 0, it's going to be 1. When x is 1, it's 0.3, and when x is 2, is 0.09. And if we were to draw a graph, we notice that the function looks like this. I did ask you guys to draw a sketch. And this is an example of a decay model. And I'm going to highlight the max. This is the max, -2 to -2, and the min is going to be 2.09. So it's going to be right here. So our min is going to be 2.09, and at this point it's going to be -2, 11. So this will be the max, and this is the min. For number two, what I would do is I draw a graph, or look at the table. Once again, we're going to clear this. So we have 3 to the power x, and go ahead and look at your table. And the interval that we're interested in is from 0 to 4, so I'm going to go ahead and draw that table. So here is the x-axis, and here's the y-axis. So we have 0, 1, 2, 3, 4. So when x is 0, y is 1. When x is 1, y is 3. When x is 2, y is 9. When x is 3, it's 27. And when x is 4, it's 81. So your graph looks just like this. I'm going to go ahead and sketch that graph. There's the y-axis. There's the x-axis. And I'll use a different color to sketch it. I'm going to go ahead and graph. So it looks just like this. So we know at 0, 1, that's going to be our min. 0, 1. And then, of course, our max will be 481. That's our max. Let me go ahead and highlight what I'm talking about. So we know the intervals from 0 to 4. And once again, 0, 1 is our min. 4, 81 is our max. And our model, this is called the growth model. For number 3, we're going to go ahead and make a table. And when we make the table, we're able to see whether it's growth or decay. We have 2, and then we have 1/5. And then, of course, we have the power to the x power. Look at your table, and we're looking at -2 when x is -2, -1, y is 10. When x is 0, y is 2. When x is 1, we have 0.4, and 2 is 0.08, and then when x is 3, we have 0.016. And so I'm going to highlight -2, 50, and I'm going to highlight 3, 1.016, and I'm going to go ahead and draw. I'm going to go ahead and draw the y-axis. Draw the x-axis. And I'm going to go ahead and press graph. And you notice that it goes like this. So this is a decay model. If you look at the y values, they're decreasing. They're decreasing. And we know that in -2, 50, that's your max. And we know at 3.016, this is your minimum point on the given interval. We're going to graph this function, and just like we've done before, we're going to go ahead and make a table, kind of see how the graph is behaving. So we're going to type in 0.99 parentheses 1 divided by 3 raised to the x power. And I know some people always ask me, where do you start? You can start at -4 if you want. I just randomly picked it, so it's -4, y is 80, -3, it's going to be 27, -2 is 9, -1 is 3, 0 is 0.99, 1 is 0.33, 2 is 0.11. And if you were to draw your y-axis and draw your x-axis and then sketch the graph, you would notice that it would be a decay model. If you look at number 8, we're going to go ahead and look at the graph. Y equals, we're going to type in 20 parentheses 1.75 raised to the power x. That 1.75 is greater than 1. That kind of indicates to you that it's a growth model. But let's look at our table, second graph. And I'll probably start with -3. So x equals -3. So the y value is 3.7. When x is -2, it's going to be 6.5. When x is -1, it's going to be 11.4. 0 is 20, right? 1 is 35, and then 2 is 61.2. If we draw the x-axis and we draw the y-axis, you notice just by looking at the graph here, this is a growth model. Okay, growth exponential model. For number 9, it says, suppose you deposit $1,500 in a savings account and pays interest at an annual rate of 6%. No money is added or withdrawn from the account. What you're going to have to type in to the calculator is your initial amount, which is $1,500, 1 plus 0.06, and remember we're going to use X as the years. So we're going to go ahead and type that in, and it says here we have 1,500 parentheses 1 plus 0.06 raised to the X power. And it's asking us how much money will there be in 5 years. So if you scroll down to 5 years, you notice that there is going to be $7.30. If you continue going down on the x-axis, which is your years, you're going to notice after 20 years, you will have in the bank $4,810.70. So if you're looking for how many years it will take for the account to contain 2,500, we kind of have to work backwards. So we notice that at 9 years, it's 2,534. So I would say about 9 years. How many years does it take for 4,000? So now you're looking at the Y value. And you notice that after 17 years, you get $4,039.20. So that's a good estimation there. So for number 9, all you're doing is using the calculator to come up with the values by using either the x-axis or the y-axis. Number 10, it says write an exponential function to model each situation. Find an amount after the specified time. So I'm going to write a population. So we're looking at A of T, and we have 1,236,000 grows 1.3% per year for 10 years. So we know that the initial amount is 1,236,000. 1 plus 1.3%. You can always say 1.3 over 100, and then raise to the 10th power. So I'm going to go ahead and type that into the calculator. I'm going to exit out of here. So I have 1,236,000 parentheses 1 plus 1.3 divided by 100. And this is all raised to the 10th power. So I have, after 10 years, I have a population of 1,406,413. So 1,406,413. That would be the population after 10 years. A population of 752,000 decreases. So now we're talking about a population that decreases. We know that the initial amount is 752,000. We know it's going to decrease, so it's 1 minus 1.4 over 100 raised to the 18th power. Remember I told you that 1.3% can be converted to decimal by dividing by 100, and that's what I did here. So this will be the population after 18 years. So I have, and it's decreasing, so it's 752,000. So what I wrote down is 752,000, and then you have 1 minus 1.4 over 100. raised to the 18th, and I wrote that in the calculator. And what I got is, I'm going to go ahead and write down the population. 5, 3. So it decreased by roughly 200,000 people, whatever was the population. So it came out to be 583,448.